job. So in the future, we just need to have Carlos say it over and over and over.
Yes, please keep repeating.
Every 30 minutes, please say it. Every 30.
So, in this video, we're doing double integral. And we just switch the order, like so. And now we integrate cosine. Cosine is sine dividing by the coefficient x. X is a constant. This x was standing there originally, so we can cancel out. And that makes the whole situation much easier. Now there's no product rule, and that's why we chose integration with respect to y first, versus with respect to x. But don't forget, you need to plug some numbers, 0 and pi. Sometimes this is actually a pretty good idea right now to sine 0 and pi. Is this x or y? Because your function has both x and y, so you might make a mistake. Where should you plug? Does your brain right now understand where to plug pi? Into here or into here?
Y.
So how do you know? Yeah, but that's because you did it fast. If it took you like 20 minutes just to integrate, you might forget. And what if you have 5 variables? So that's why it's a nice habit sometimes to write down that this is y equals and y equals. This is internationally known. I was taught like this as well in Ukraine. To sign sometimes to help your brain to see that. Yes?
Can you tell us how you did the U substitution and
I will write down the shortcut. That's actually a very good idea to write down the shortcut instead. I used the shortcut, and I have a YouTube video about this. Like and subscribe. And the shortcut is integral of as the cosine ax plus b dx is. You just integrate cosine. You know that integral of cosine is sine. Copy the function inside, that's U substitution, and divide by the leading coefficient. That's a shortcut. I'm teaching it at my classes. I have video about that. So because leading coefficient is leading constant. In this case, x is a constant. That is why I'm dividing by this x. Make sense?
It's been a while since we've done this.
Yeah, that's been a while. It's been a while when we did U substitution.
What?
Now, don't touch the integral until you finish the inside part. X cancel out, which is very nice. Plug pi into y, remember? So it will be pi x. Minus plug 0 into y. Well, this one doesn't matter because it's 0. dx. So this guy is 0 definitely because 0 times everything is 0, but pi x is not necessary. If x is 1/2, that will be pi over 2, which is not 0 anymore. So we need to continue integration. But now we're integrating a very simple integral, px dx, sine of, what did I say, p? Sine, p is a Russian way to say pi. Actually, only Americans called pi. I told you before. Nobody else called pi. Everyone called p, phi, c. You guys called pi, phi, psi.
Something BC.
That's why we don't have this joke about pi day and stuff.
You're missing out. Yeah.
That's true. That's true. We don't have pi on discounts.
It's actually P Day. It's a birthday.
It's a p day, yeah. I know it sounds weird, but it is. It's a thing.
Okay, we watch the YouTube video.
Jacob is making inappropriate jokes in classroom. How sad is that? What is integral of sine minus cosine? Pi x minus cosine, because derivative of cosine is minus sine, dividing by the coefficient, leading coefficient. That's a shortcut of U substitution. A bar 1 and 2, and I'm not signing 1 and 2 anymore because it's only one variable x in front of me. So I'm signing only if there's several. So again, this is, I forgot to sign. It's not just shortcut, it's U sub shortcuts. Same with sine. Integral of sine is minus cosine. Copy the part inside. If it's linear, divide by the leading coefficient. The shortcut only works for the linear stuff. Like so. Now, plug the top minus the bottom. Minus cosine of 2 pi over pi minus cosine of 1 pi over pi. This is a very unusual way to write it down. You could actually in your mind switch the sign, but I wanted to have good notes. Don't forget there's a negative sign when you plug top minus the bottom. So you have minus 1 over pi and minus 1 over pi. That, do you agree? Minus, what is cosine of 2 pi? 1. Then, what is cosine of pi though? Minus 1. So you have 3 minuses here. Minus, minus, minus. That is minus. That's gonna be, thank you, good job, minus 2 over pi. That is the answer. So we avoided doing integration by parts from the very beginning because we switched the order of integration, and that is possible for almost all cases when functions and surfaces are continuous and smooth. Pretty cool. So that is why it's going to be creative. I give you the integral. Maybe it's equally easy or hard to integrate with respect to x and y, and you choose how you like to do it. Now imagine x, y, z. You can choose any order, and that makes it pretty creative because your eyes should see, oh, there's only, this is how I see it as a student. Oh, there's only one y over there. Definitely it'll be easy to integrate with respect to y because it's only one y. But there's a 2 x's. That's a product rule or chain rule. I don't like that. So that's how your brain should see it. Oh, there's only one z. Let's do that first. Or only phi. Let's do phi first. And so on. Yeah.
If double integrals are looking into a 3D space, I'm assuming that triple integrals are looking into the 4D space?
We're going to do 4D spaces definitely soon. And then, yeah, we're going to 4 dimensions. With respect to time, it's going to be 5 dimensions, actually, very soon, after the exam.
Go to 6 dimensions?
After the exam. As mathematicians, we go to n dimensions. So for us, this is nothing. I'm not joking, by the way.
Yeah,
my dissertation was about like n dimensions and stuff. So.
Right, thank you.
But yeah.
What does n dimensions look like?
I can tell you after the class, actually. It's pretty interesting. How about this? This is what some of you have asked about. This is 12.2. 12.2. We're just talking about integrals right now, but integrals can be taken with respect to different surfaces and regions. What?
12.2?
Yeah. So integrals over the general regions. Let me check. I think it is 12.2. Let's check the syllabus. I just want to have more stuff with integral without pointing out the chapter because it's easier this way. 12.2, yeah, that is 12.2. So integrals over general region. Some of you asked me last time, that was so smart, you asked me, is it always above the rectangle? No. That is exactly how it started in Calculus 1 class. Oh, don't forget, we're integrating from 2 to 5. Yeah, but what if there's like a function and the function? Remember we did top minus the bottom, right minus left?
No.
That was like 2x squared here and 5 minus sine x.
Oh, no.
Now we're going to do it right now.
No.
It's going to be very hard. It's going to be very hard. So let's see. Because now, that was very hard thing in Calculus 1 class. But now it's going to be in 3D, so it's kind of hard thing inside of the hard thing. We have done cases where the base of the cake, let's say if this is a cake, is a rectangle. But what if it's not? Like a cloud. I told you, the cloud is raining, so it's not a rectangle. It's like all kind of type of bases over here. So we did this. We did like so. R is a rectangle. Why? Why it's always rectangle? Even cakes can have different shapes. So let's have different shapes. You see, this is also rectangle. This is also rectangle. That is very restricted. What if I want a general one? So the base D, like this is base, which is general region. So the chapter has a name: integration over the general regions versus over the rectangles. To be honest, we're never gonna ask to integrate versus rectangles. It's too simple. So we will go to something more complicated, which is more pliable.
So we're not going to do the easy one, we're always going to do the hard one?
You can see that this is reasonable by comparing the graphs and remembering the double integral is the volume under the graph. So here there is. The volume is this all cake, but the base of the cake, it not necessarily have to be the shape of the square. So here how it looks like. Remember these graphs, top minus bottom, right minus left? Yay, we're going back to that time. A plane region D, so write down this one, this is important. A plane region D is said to be a type 1 if it lies between the graphs of the two continuous functions. Oh, yeah. It's kind of review of Calculus 1 material. To be honest, it's not new. Right now, it's not new. We had this before. We called it area between graphs. Because at first we told you, oh, it's the integral is area below the graph. That was a lie. The integral is area between graphs, but below was 0 at first. And then we told you, actually, it can be anything, right? So we taught you top minus the bottom idea. Integrate or scan, CAT scan goes from top to bottom. So top minus the bottom. It always goes large minus small. So whatever is on the top is bigger than whatever is on the bottom, and whatever is on the right is bigger than whatever is on the left. So this is type 1, whatever is at the top and the bottom. So top minus the bottom from A to B. Copy this, and then let's do the example. So the material accumulates pretty fast, and you will see that. Done?
No.
Oops. So these types of type 1. Type 1 is top minus the bottom case. Type 2, you can guess, will be like so. Right minus left.
Oh.
Remember?
That's like a disc and one.
So you see, x, bless you, is fixed between numbers, but y is fixed between two curves, top and the bottom. Some examples are below. So let's do the example. And they never tell you which case is that, right? So that's also a hard part here. You have to figure out yourself. Find the integral, double integral. This is notation. If we don't know the edges, usually you put d below. But when you code, it's hard to do it, so they put d over here. But actually, it's supposed to be below, like so. X squared, y squared, y dx dy. So first, now we know we can switch the x and dy, but we don't know what d is. You can perform integration if you don't know what d is, but it says that d is the region between two curves, x squared and y minus 8 squared. Who's keep yawning today? No, don't ruin my energy here, okay? So, let's do it. This is the picture of the cake, if you want to see the cake. This curtain in the air is your z, right? Like three-dimensional surface, x squared and y. But the bottom is this d. D is at the bottom. It's the base of the cake. This is my d. We just need to figure out not only how d looks like exactly, it just says d is between x squared and 8 minus x squared. What does it even mean? But we also need to know the borders, like what is this? What is this? These points. How to integrate from what to what? Left, right, or top, bottom? Hard to say. Step 1. Step 1 is always a picture. Without a picture, you cannot do it. So people have to learn how to be comfortable with sketching the graph. Sketching the graph. And we're looking for the volume below this curtain, but above this restricted region, which was created by two lines. The line on the left is the parabola looking as 8 minus x squared, and the line on the right is the parabola y equals x squared. This is looking something unusual at what we used to before, because this is your z and this is my x, and this is my y. So x squared is here at 0, it is 0, and then it looks like up. So you need to tilt your head to see the floor. The two-dimensional piece is going to be your floor, which we did in calculus 1. Floor is level, no, floor is 2D case. So let's sketch the graph in 2D. In calculus 1, we were supposed to sketch this graph right away. Graph between 8 minus x squared and graph between an x squared. Now we have two graphs. One is 3D and the second one is in 2D. So because we're going into 3 dimensions here. Let's sketch the 2D graph. 2D graph have two parabolas. In blue, it is y equals x squared. Y and x. Y equals x squared. That is my parabola in blue. In red, upside down parabola shifted by 8 units up. Upside down because of the negative sign, plus 8, so it goes over here to 8, and it looks sad, like so. It's concave down. Y equals 8 minus x squared. This is my 2D picture, which is a floor of this 3D picture. This floor restricts the volume because the volume below this curtain may be like this huge. But this floor tells you, no, I only need this base. So tell me the volume only above this base below the curtain. So this is my picture. This area over here is D. This is D. That is the region bounded by x squared and 8 minus x squared. This phrase is supposed to trigger you, trigger warning, exam 2 in calculus 1 class. Find the region bounded by.
Oh.
Maybe it was calculus 2 actually.
It wasn't calculus.
I think it was second one, yeah. Find the region bounded by. So we need to find the points because the double integral will be created from those points. So what are the points of intersection? And this is case 1. Let's see. So step 1, sketch the 3D picture. Step 2, sketch the 2D picture. So step 1 was 3D picture. And now we know step 2, 2D picture. Here it is. Find points of intersection. This is case 1. How do we know? Type 1. Type 1 is where you see the graph in 2D, top minus the bottom. One function is always on the top, then another function. Always. Makes sense? So they don't switch, because sometimes they switch. In this case, they don't. One is always on the top of the another one. So the scaling will be top minus bottom, top minus bottom, top minus bottom. Yes?
To scroll down a bit.
Yeah.
Why does it say z is equal to x squared y? What does that mean?
The graph was this 3D shape is this. X squared y.
Okay.
Mm-hmm.
Alright.
Yeah. Good question, yeah, because z was not even mentioned before. So what we have here, we're gonna do scanning. This is case 1 or type 1, which is top minus the bottom scanning case. Top minus the bottom. You need to know which function is at the top and which function is at the bottom. Red one, 8 minus x squared is at the top. So that will be my top function. And then this one will be a bottom function, x squared. Since we do that, integral will have top function minus bottom function, and then we should have x-axis. Where the shape is starts, and where does it end? It starts from top to bottom, from this function to this function, this function to this function. But where does it end on the left and the right side? It ends on these points. We need to find these points. Points of intersections. Points of intersections. How to find these? You just set a system of two equations. Y equals x squared and y equals 8 minus x squared. And solve it the way you like it. For example, you can just plug in x squared or set them equal to each other. X squared, 2x squared will be 8, x squared will be 4, x will be
Plus or minus.
plus or minus 2. Good job, Panda did not cry today. Minus 2, did not forget about that, and 2. So now we know the 2 points. Minus 2 and 2. So my 2D region is restricted from minus 2 and 2, and from left to right, then from top to bottom, 8 minus x squared to x squared. This is exactly CAT scan, but in 2D. If you want to make a scan of the flat fish, you put a flat fish, it will do from A to B, top to bottom, done. So, I don't know, that was a weird example.
It is flat.
What is flat animal you can think about?
Yeah, there's no flat.
There is no indefinite flat.
Stingray or manta ray.
Oh yeah.
Stingray, that's a good one.
But they aren't flat.
Yeah, they are. Well, on one side, yeah.
They still have.
And the irrelevant discussion have started.
Kansas is flat. Kansas.
Step 3.
Oh, the Earth is flat.
Oh yeah, the earth. Yeah, exactly, the earth.
Step 3. So, we always do bigger minus smaller. So we need to write down that in this case, we always do bigger minus smaller. So y is between the bigger function or larger, I don't know which one you prefer, and smaller. Smaller, right? X is also between bigger and smaller, which is minus 2 and 2. But y is restricted between functions, which I already mentioned to you. The one on the top is 8. Let's keep consistency. 8 minus x squared in red. And the one at the bottom is blue, x squared. So top minus the bottom. And that helps us to build the integral. Finally, we can build the integral. I would say this is already step 3, but we can do step 4, I guess. Step 4. Volume is a double integral. That's why I did not understand when I was a TA. Why are we doing shell method? Why do we do washer method? I was very confused because you can just do double integral. In my mind, volume is a synonym of double integral. What is the volume of Carlos' body? Double integral. What is the volume of that water bottle? Double integral. Why did we need to do shell method and unfold the bottle with layers? I did not understand that. So I had to learn it before teaching it, like next week, you know. So volume is a double integral. There is no reason to question that. The function z comes inside squared and y. This is my function z. Then we have dx, dy. The order, as you know, doesn't really matter, but now we will have to figure out how we're gonna proceed with this. This d means there's a region that bounds, restricts the 2D picture. So now we need to figure out how to write it down. Equals. So integrate. You can start with the easy one and then proceed with the hard one, or you can start with the hard one and do the easy one. Doesn't matter. Let me do dx outside because we usually do numbers outside. Usually the numbers should be the very last step to plug. You will see why later. dx has numbers. So while y is between functions, x is between -2 and 2. So that is easier. That is definitely a good case. That is not easy. So x is going to be from -2 to 2. While y, let's put it in red, dy. You see, the moment I put it inside one level, I know that now integral should be about dy. Top minus the bottom. 8 minus x squared was at the top. X squared is at the bottom. The function stays the same, x squared y. And you finished. Building this integral gives you lots of points on a test. Just creating this integral, I would already give you lots of points because it means you understand.
You have to solve that?
Yes. We still need to solve it. Yes.
Oh.
Actually, multiple choice, maybe not. Multiple choice, maybe you'll have list of integrals.
For this one, is the y the top minus the bottom? Because in the beginning of the function, it's given as y equals x, 8 minus x and 8 minus x squared and y equals x squared.
Yeah, it's these ones. I know what you're asking, but
Yeah, so because it's given in terms of y equals, then we.
yeah, tricky. That's a good question. If I give you this as 8 minus y minus x squared equals 0, you have to choose yourself, you know. It's a good question he's asking. Did we just guess because it was given like so? If you remember calculus 1 and 2, you have to be creative about this. And sometimes we give you like this, and you will solve it as a root. And you'll do minus plus. So for now, it's just an easy example. That's why it's straightforward to see y equals. But no, it will be harder.
So if for example, if I had chosen x, then I would have the points y4 and y4.
Yes,
And
he's
it's
right.
2,
Yeah.
4.
Yeah, he is right. If he chose case 2, and case 2 is right minus left, then you will have fixed points for y, say -4 and 4, whatever it is, yeah? And then x equals, like whatever, sine y, right? And then x equals square root of y. So we're going to do this as case 2.
Well, the reason I'm asking is because in this case, y is 4. If your x points are plus or minus 2, the y points are 4. They're both 4.
Yeah.
No, but that is not good because that's just list level. It's half of the D region. So we need to do either the top, or the right, left.
Okay.
Yeah?
All right, okay.
Make sense?
Yeah. Okay.
I got your question, yeah. So building this integral was already a big deal. And that's why, taking this class is important. You need to understand where this integral even came from. Now you can choose how to integrate it. You have a choice. You want to integrate with respect to x? Usually it's easier to integrate right now with respect to y because it's only one y and it's not squared. So let's do that. So Let's keep dx waiting from -2 and 2, but let's integrate y. Let's integrate x squared y with respect to y. That's going to be x squared y squared over 2. Maybe I'll keep it in black. X squared is a constant. Y becomes y squared over 2. A bar from x squared to 8 minus x squared. And now dy disappears completely, only dx stays. You can keep putting parentheses if it makes you if it makes visually better for your brain. You can put parentheses inside. Plug the top minus the bottom. -2 and 2. And I will have, and now you need to understand where to plug, into x squared or into y squared. That's why maybe write down y equals. Don't touch x squared, it's a constant. Y squared becomes 8 minus x squared over 2, 8. Minus x squared over 2, and that is also multiplied by x squared dx. Simplify and move on. Kind of, to be honest, I think it would be easier to integrate with respect to x first. I just realized it right now. And we can compare.
I like it like this.
So you can simplify everything, which is like, just expand, expand and distribute, plug the top minus the bottom, integrate with respect to x, and then you will get, look how smart I am. I have the answer. Over 15. I know, it is like true cheating, honestly. And this is supposed to be positive number, as you can understand, because it is volume, units cubed, volume. But the strategy is the same. You draw the picture, you choose the case, and then you build the integral. When you build the integral, you start integrating it. We could try right now integrating with respect to x squared x and see if it's easier. But, something tells me it's not going to be much easier. Important note. Let me finish the note and I will ask if you have questions. Important note. Integral should not have only constants. This integral, double integral, should not have just constants. That means you messed up. Constants. There should be some variables somewhere. So make sure the outside integral have constant. There will be like more constant or less in some examples than others, but there should be some kind of function there. Unless it's a rectangle, then you're fine. But in other cases, it means you lost some kind of shapes of parabola or cubic function or sine and so on.
Oh, Professor?
Yes.
Will our end answer ever have a variable in it?
What?
Will our end answer ever have a variable in it for area?
It should.
Variable?
Yeah, we'll have a variable at the end ever. Like instead of like 10, 24, like have 10, 24 x over 15.
Good question. The complicated answer, yes, of course. We have upper level math that does have that. It's called variable volume and stuff like that. In this class, no. In this class, volume will have finite answer. That's why I was thinking like, well, which one to answer. Yeah, in upper levels, we even have increasing, decreasing volume. So there's a variable with respect to time, for example, and something is keep increasing or expanding, or maybe even decreasing the volume with respect to gravitational forces, slowly shrinking something. So in upper division physics and math classes, we do that, but not in this one. Yeah, good question.
Do you want some of the units for the exam?
No, I'm the one who don't like units, so I don't usually. Okay, but I will be trying to answer questions about units when we need to. So let's see if we still can do one more. Volume of paraboloids and stuff. That would be interesting to work with. But in general, case 2, I guess we should do at least one example with case 2, which is, let's see, smaller, bigger, 2 minus 2x. Yes. Okay, I found case 2.
Are these for our homework?
Nah, I'm thinking either homework or not.
I would not.
Let's write down some kind of important information to have this in front of us in general. So, important, some kind of note, important. And we're going to do case 2 on Friday. Right minus left. Top minus the bottom is the more obvious for us as humans because we know, what's the volume of this building? Oh, you take the roof minus the bottom. It kind of makes sense. Right minus left is more tricky. So your brain kind of doesn't like looking at things from right to left for some reason. And that's why I want to do it later. But it's a very interesting property. Sometimes it will be handy to know that when you have double integrals from C to D, from A to B, products of two functions, f of x and g of y. Okay, which d I should put right now, dx or dy? Who understands finally this idea?
X.
How do you know?
Because A and B are the inner integral.
C, do you guys understand that dx should be right now because a and b goes inside, right? And then c and d are outside. So the moment I fix one of these, the other one should be consistent. Whatever is inside should be inside. Whatever is outside should be outside. So if you have a product of two functions, it's handy sometimes to break it into products of two integrals, and then it will be easy to integrate. Integral of f of x dx, integral of c to d, g of y dy. Luckily, we do have lots of products and applications. So even the epidemiology modeling has lots of products when the number of people who got sick, infected people, is multiplied by how efficient is vaccination is. So those products, and then if you want to know how fast it's all changing, you differentiate with the product. But if you want to know how fast it's accumulating, integral is accumulation of sums. If you understand that. Integration is not just area or volume below something. Integration is a fancy summation. Or I would say, if you do 2 plus 2 plus 2 plus 2, that's 2 to the 4. But what if you do 2 plus 3 plus 0.7 plus 100? Integral will collect all of this. Integration was created for collection of different values. So it's a fancy next level addition. That's what integration is. So if I want to know the accommodation of the patients, all with respect to how efficient the vaccine is or medication they're taking, that will be integration of the product. And that's why this is actually very applicable in real life. That's a cool idea here. So we're going to do that. Put this in the box. Questions? What do you think? Signing so hard again. Then we can definitely stop here. It's fine for today. Quiz on Friday, so don't postpone your homework. And ask questions at the forum.
I'm not gonna be here Friday.
Then just